All right. I plan to drink a lot of water, so you really don't need to clap every time I do that. Otherwise, we won't finish in time. Also, every time I give a talk, I want to start off by making a photo of the audience so that I can remember the talk. So I plan to share this on social media. If you don't want to be on this, please just hide your face or something. And with this layout, I need to do multiple photos. So I'm going to do one over here. All right, then one in the middle. Yeah, or a widescreen photo, that could also work. And one over there, yeah! That's the audience. OK, perfect. Perfect, thank you. OK. So, yeah. Oh, this is out of sync. No, it's OK. OK, so, yeah. That's me. My name is Dominik. I'm a software engineer from Vienna, where I currently work on the design engineering team at Sentry. I started 2 months ago. You can find me as TK Dodo online almost everywhere. And also for the last almost 4 years now, I've maintained the popular open source library React Query. And Tejas has taken away half of my talk already, so I wanted to ask quickly, who has heard about React Query before? Please raise your hands again. OK, that's a lot of people. Why do you keep your hands up? And who has used React Query, like just really worked with it? OK, still, wow, so many hands. OK, lots of people. That's great. That's great because it means you're actually Tensor query, as it's called these days. I forgot about that. OK. No, but really, that's great, because it means you're actually going to know some of the APIs I'm going to talk about. Because today, I want to walk you through some of the API design decisions that we've made in React Query over the last couple of years. I want to tell some stories about things that went well, but also highlight some trade-offs that we had to make. And there are some things that didn't go so well. And I want to talk about them as well. And yeah, maybe there are some lessons that we can all learn from those. And I've talked about this topic before, but here at React Paris, I got a bit more time, so today I can do the extended version of the talk, which is great. And I really want to talk about this for 2 reasons. Number one, I think API design is hard. This is not my quote. Julius said that. He's a really smart guy. He maintains tRPC. He also contributes to React Query from time to time. So if he says it, I think it's probably right. And the second reason is I think React Query has a really, really sweet API. And I think that's part of why it has become so successful in the last years. Now, of course, I can't take the credit for that because Tanner Linsley made the library. He designed most of the APIs. And he actually has a really good tweet where he summarizes the goals of the library, where he says that the Query API is actually medium-sized when you unpack it all. But the most important part is that you can understand and learn how to use it by starting with a single function that provides 80% of the entire value proposition first try. From there, the rest of its API can be gradually learned if needed. And I think that's what it takes for a library to become popular. It needs to be both minimal and intuitive, as well as powerful and flexible. But for any given API, I think those 2 things are usually on the opposite side of the same scale. So if we take a look at array.join, for example, I think that's a really good example of a minimal API, super intuitive, does one thing, and does that very well, and there's no surprises with it. And then on the other end of the spectrum, we would have something like array.reduce, which is very powerful. I mean, we can implement all other array methods just with reduce. But it's also quite complicated to read and understand sometimes. And if that's the only thing that we have available, we would also not be happy with it. So the missing part here is the second scale, and I think that should be application complexity. Because as the app complexity grows, we would actually want our APIs to become more powerful and flexible. Now, on that scale, I would put useQuery right about here on the bottom left, if we call it with the 2 minimal required arguments, which is the query key and the query function. Now, that's a quite simple API to use, but it already gives us a ton of things. Like it gives us caching, requested duplication, there's global state management, it handles loading and error states, and there's like a really long list that goes on and on, what you get for just this function call. And then later, we might want to add a mutation to perform an update and then tie it back to the query with invalidation. And that's already a bit more code, but I think we can get really, really far with just those 2, so I put the mutation right about here. And now, as our app complexity grows, I think so does the flexibility of the query APIs that we're using. Because as time goes on, we might need to make an optimistic update or maybe an infinite query, and those are a bit more work. And then, further up to the right, we would have our plugin system, and then also our very low-level cache subscriptions that we use, for example, to build our own dev tools. Now, those are not things that you need to learn when you're just starting out with the library, but I think once you reach a certain application complexity, I think you might be happy that those exist as well. And I think we got to this API that kind of evolves with you through careful planning, lots of iteration, and also a couple of major versions. And that gets me right to the first learning that I had as an open source maintainer, which is that I'm no longer excited about major versions. And I think you probably shouldn't be either. So API design is hard. I think I said that already. But it's especially hard in open source because we can't easily revert the decisions that we're taking. Now, that would need a major version, but we can't do those breaking changes lightly because every major version really has to be a marketing event, right? We need announcement tweets and blog posts and even videos. Because when the users hear about a new major version, I think major sounds huge and great and good. So the immediate question is then always, what are the new features? Now, the problem here is that major versions aren't about new features. They are about breaking existing APIs. The features usually go in minor versions. I mean, we all remember React hooks. They came in exactly version 16.8, not 16 or 17. React Router added route loaders, a great feature in version 6.4. And for example, Bun added Windows support in version 1.1. Now, that's because adding new features rarely needs to break an existing API. Of course, there are exceptions when we're redesigning something from the ground up, and that enables us to then build some new features on top of that. Now, one example from React Query where this happened was actually our initial Spark for version 4, because we got some bug reports around how online and offline support worked in version 3. And the issue was mainly that Query had some assumptions about network connectivity when doing retries. Now, that wasn't great if you're doing something that isn't data fetching, and we also didn't allow to customize that or expose that to users. The problem really was that we couldn't fix or amend this in a backwards compatible way. So we thought of a completely new model and shipped a new network mode option in version 4 that also integrated well with additional caching layers like the one that's built into the browser. Now, this then proceeded to become our flagship feature for version 4, but usually features come in minors. So when I got asked about what the new features in React Query version 5 are going to be, I really started to sweat a little bit. Because I don't know if you've done the migration, we broke a lot of APIs, and we didn't really have any features planned. So what we did was we added some APIs or some features that we could honestly also have backported to version 4. Now, I don't think that's great, because it means we're actually withholding features from our users just to have this great marketing event and great new version. I think a system would be great where we could decouple the breaking changes from the marketing events. And Anthony Fu had a great suggestion where he wanted to extend the usual semver into something that he calls epoch semantic versioning, which allows us to better communicate about the intent of a breaking change. Because in epoch semver, every marketing event or significant overhaul just gets an increase by 1,000 major versions, and every other breaking change gets a normal increase. The rest pretty much stays the same. Now, the nice thing about this is that it's actually backwards compatible with the usual semantic versioning, but it can give people an indication about how breaking something is. For example, Alex is the creator of tRPC. He once said that tRPC version 10 should have really been seen as version 2 because this was the first time where they made some big syntactical changes. Now, this worked out for tRPC because 10 in binary is 2, so you can kind of see that this works. But if they were using something like epoch semver, they could have started out at version 1000 initially, then progressively moved on to 1009, and then made the real rewrite with version 2000. I think that's a nice idea, not something that people will adopt immediately, but just something to think about. And yeah, maybe when a new version comes out, don't think about what's new, but think about what's breaking instead. Okay. So I'm no longer excited about major versions, but one thing I'm still excited about is TypeScript. Now, don't worry, we're not going to go into library-level TypeScript today. This is real code from Recre. But I think if you're building something, it helps tremendously to think about the types from the beginning and design your APIs with types in mind. Now, I know there are lots of people who say that we can always add the types later and we should just make it work first. I don't think that's right, because when you're working with JavaScript, we can build all sorts of cute and dynamic constructs that will work at runtime, but are then later on very hard to type. Now, almost everything is doable in TypeScript with enough magic, but all magic comes with a price, and in this case, the price is usually type complexity and maintenance burden. I really like that phrase that if something is hard for a compiler to figure out, it's also hard for humans to understand. So if we are having troubles to express what we want to the compiler, maybe the API that we've chosen isn't really the best. And one of these cute and dynamic constructs we had in React Query was actually useQuery itself, because you could call it in 3 different ways with different positional arguments. Now, there's no good way to make this work in TypeScript except with overloads, which is what we did. But overloads are also problematic because they don't have really good error messages. What TypeScript does is it just tries all overloads in order, and if something's wrong, it will show the error message for the last overload that it tried. But that can be completely misleading. Also, we had to do some runtime checks to actually merge the 3 ways into the same object anyways. And yeah, who needs 3 ways to do the same thing? So what we did was, in version 5, we removed 2 of those overloads. Now you can only call useQuery with the option syntax. And with that, we've reduced our complexity internally a lot. We went from 125 lines to just 25 lines of types. So I think had we started with types in mind from the beginning, I think this is the API that we would have landed on right away. OK, now enough about TypeScript. I think one thing that always comes up when a library becomes popular is that users want more features. And to be honest, managing a demanding user base is one of the more tricky things in open source, because of course you want to listen to users' feedback and address their needs and implement the feature requests that they have. But on the other hand, if we just add every feature that is requested to the library, it becomes unfocused and maybe bloated. And that will then reduce the adoption again for newcomers because it also becomes more complicated. So we have to balance this somehow. My advice here would be to just really take your time before you add anything to the library. I think users can be very demanding. But in the relationship between the open source maintainer and the user, it is actually the user's job to tell us all about their use cases and how important that feature is for their deadlines. But it's also the maintainer's job to keep the bigger picture in mind. Will this API work for everybody? Are there cases that we haven't yet thought about because the reporter didn't know about them, and so on? Now, one example where I got this wrong was the refetch page API for our infinite queries. Just for context, infinite queries are our way to make building these doom-scrolling pages that everybody hates relatively easy to do. I'm really sorry about that. But technically, an infinite query is just one cache entry that is chunked up into multiple pages, where each page depends upon the previous one. Now, quite a lot of people have raised the concern that when there's a refetch happening, we would refetch all the pages. And they wanted to have a way to just refetch a single page in this list. And we thought, yeah, that doesn't sound too bad. Sounds reasonable. So we're going to add an API called refetch page to our existing APIs, like in validated queries, so that the user could then decide if the page should be refetched or not. So now that API was a mistake for a couple of reasons. I'm going to finish that bottle, I think. So for one, I think it's a bit weird and confusing that refetch page now exists on something like invalidate queries, but those functions don't really know anything about infinite queries or normal queries, right? So if we match with our query key something that isn't an infinite query, this function, this option just wouldn't do anything. Now, for technical constraints, we could also only add this method to our imperative functions. So if an automatic refetch would occur, we would still refetch all the pages, and that's not consistent. And it's also the easiest way to get incorrect data on your screen, because if you have an infinite list where each page builds upon each other, and you refetch one in the middle, you might see duplicate data, or your UI can get weirdly out of sync. So that's not great. And what we did was we took a step back and then asked our users, what's the real use case that you're using this API for? And the answer was always the same. If the user scrolls down a lot, we have lots of pages in the cache, and then we don't want to spam our API server when a refetch happens. And I think that's fair, but we tried to find an API that solves this problem instead. And eventually, we landed on the max pages option on use infinite query, which simply allows you to limit how many pages are in the cache at any given time. Now, I think this API is a lot better because it solves the problem holistically, but from a different point of view. It will work for all kinds of refetches, and it will coincidentally also speed up rendering if you're navigating to a page that has cached entries, because there won't be as much to render. So my takeaway here is that we landed on a suboptimal API too quickly, and had we given ourselves more time to really understand the problem that we're trying to solve, we could have come up with something better. The only alternative really is to ship APIs with an unstable or experimental prefix. We also do this from time to time. I did that 2 days ago with the streaming adapter that we shipped. But I don't know if users really want to try out things that are labeled as experimental. And I also get messages like this, which isn't really reassuring. So that's also not great, I think. Another API that gets requested quite often, actually, is the ability to debounce some API calls, right, in React Query. So you'd want that, for example, when you have a search field and you want to do some auto-filtering. Now, unless you want to fetch on every keystroke, you would need a way to debounce that. But this is an API, it's a good example of an API that will not make it into React Query, simply because it's not its responsibility. Now, there are lots of ways to do debouncing, and you can do it differently. It can get quite complicated. Also, you might need more than just a number as an option. So yeah, this also adds more bundle size for users who don't need that feature. There are all kinds of trade-offs with that. But the good news is that you can relatively implement this in userland by using your favorite use debounce implementation. I think the use hooks package from UI.dev has a good one on that. Or you can just write one yourself. Now, the way this works is that the filter contains the current input to display for your users. But you take the debounced filter and pass that to the query to not make a fetch on every keystroke. Now, this inversion of control is a great way to give users the flexibility to implement features on their own, but it still allows us to keep a small API surface. Now, the query key is a bit special here, but we can get inversion of control for other options as well, simply by making them a function. Now, one example here is that I had a discussion with a user who said that this refetch on window focus API is great, but the default behavior is not good if the query is, for example, in an error state. And I agree, this might not be what you want, but we can't just add a separate option for that. I mean, that would be something like refetch on window focus if error or something. That's not really good. So instead, what we did was we made this option accept the callback function that gets the query passed, where the users can just derive from that what they want. So they can implement this specific feature, but also similar features directly in userland. So by now, we've made almost all of our options except the callback function. I think it's a pretty cheap trick to make users implement certain behaviors depending on different states of the query. Another learning that I had is that when we want to solve real-world problems, I think we should be pragmatic about it. This often involves trade-offs, for example, balancing theory with what works in practice. Now, the tweet from Tanner I've shown before actually goes on because it's a long-form tweet. And he continues to say that the query API it provides just enough abstraction that you'd never want to replicate its core internals. but still enough freedom and composition that you're not wanting to burn it to the ground. I designed it to be practical, to get stuff done and move on. And I love that. And I think that if we have the choice between doing the strictly correct thing and the practical thing, I would always prefer to do what's best for most users. Now, one example I have here from React Query is the typings on our arrow fields. So the query function needs to return a promise, and that can have a certain result type. For example, an array of tasks in this case. But if an error occurs, we don't know what kind of error, what type that error has, because in JavaScript, we can literally throw anything, not just errors. So technically, the correct thing here would be to type the error with the type unknown. But this isn't very practical, because it means you can't even access something like error.message without getting a type error or without doing some type narrowing first. Now, we've had this behavior, and it has led to users overriding the type parameters to useQuery to get the behavior that they want. But I think this is worse, because first of all, it's more boilerplate to write. And also, useQuery actually has 4 type parameters, and this basically ruins the type inference for the other type parameters. And if you want to use a feature that needs those, like select, for example, those won't work anymore. Now, I also think that for applications, the best TypeScript code just looks like plain JavaScript. So we did the practical thing and set our errors to default to the type error as well. Now, I know that this isn't 100% correct, but I still think it's the better default choice for most of our users. Because it's generally considered a good practice to only throw errors or subclasses of it, and there are also lint rules to enforce that behavior. But just in case, we've provided a way to opt out of this with module augmentation. Now all you need to do is extend our register interface and set the default error back to unknown to get that behavior again. But really, I would just stick with throwing errors. It's probably better. Right, now, sometimes I think doing the right thing for our users can also mean taking something away from them. We might have an API that we've released that we've come to think that was a mistake. And if that's the case, I think we shouldn't be afraid to also remove things, because sometimes really less is more. Now, I know that removing things can really upset users, because why would you take something away that works for me, right? And I really got to experience this firsthand when I announced that we were going to remove our callbacks from useQuery in version 5. This announcement was not well received at all. Really, it was a mess. And I totally get that, because it really looks so convenient and clean to have this nice separation between the query function and the side effect that we want to run. So, why is that bad? Well, the devil here, of course, is in the details. Specifically, it's not really clear when this callback will be called. Will it be called right after the query function, fetch task is called, or whenever data gets put into the cache? Because there are other ways to get data into the cache, for example, with query client.setQueryData. Now, users had different expectations about how this should work, and we also changed the behavior between version 3 and version 4 because we weren't sure. So yeah, that's one of the reasons what can be surprising here. But what's even more surprising is that the onSuccess callback sometimes wouldn't run at all. Now let's consider this example where we want to fetch a single task, and we want to use onSuccess to fill some local state with it. Now, this might look reasonable if we want to pre-fill a form with that task. But the problem here is that this state syncing that we're doing can easily get out of sync. For example, if our query has a stale time set, or if we have some other ways of having pre-fetched data in the cache. Because when we change the ID here to switch between tasks, and we have good data in the cache, the library will just give it to you synchronously without making any refetch. So the query function won't run. So onSuccess will also not be called, because there's no time to run that side effect. Everything happens synchronously. Now, this can lead to issues that are very hard to debug, because they are dependent on timing. Now, the second reason why this is not a great API is actually about closures. Because what happens if we call the same query in 2 components? would we want to run the callbacks only once, or would we want to run them once for every component? Now, if we do something like logging or error reporting, we probably only want to do that once and not twice. But in the case where we close over something in our callbacks, like the setTask function that is local to a component, we need to run it more than once, just like a use effect would run once for every instance. So I don't think there's a clear indication here what's right. It's just very ambiguous overall. And that has led us to believe that the callbacks are just not a good API to have, because we want our APIs to be simple, intuitive, and consistent. Now, the callbacks on useQuery, first of all, look like they fit these criteria, but they can actually produce bugs that are really hard to trace once your application grows. So that's why we've deprecated them in version 4 and removed them in version 5. Now, that was almost 1.5 years ago, and I still think it was the right move. And I'm happy to see that other libraries are moving in a similar direction. Now, the maintainers of the Apollo GraphQL client have recently announced that they're going to deprecate their lifecycle hooks as well, simply because they have long been the cause of confusion, bugs, and frustration for many developers. All right. Now, lastly, I think even if we keep all of these points in mind, no matter how well we try to design an API, some people will be unhappy with it. And they will usually be the loudest. Now, open source maintainers are obviously not immune to making mistakes. So the chances are that eventually we will release an API that is not well received. I learned that lesson the hard way with version 4 of React Query, where we made some changes to our primary state machine. Now let's take a look at that search example from before again, but let's see what happens if we want to handle loading and error with the derived Boolean flags is loading and is error. This code worked perfectly fine in version 3, but in version 4, what would happen is that you would see a loading spinner for all eternity, which is not good. Now the reason for this is that queries that start in a isLoading state, queries that start in a disabled state would also be in the isLoading state. And that's why then the if statement renders the spinner. Now, this didn't sound as bad when we made that change and implemented it. But there are also reasons for it, obviously. But when we take a step back and you look at this behavior, if you know nothing about React Query, I really think this is a really bad API. Like, it's horrible. No excuses for that. Did anyone stumble upon this when migrating? Yeah, a couple of people. Yeah, sorry, that was not so great. But I got messages, I got these comments, and I agree. This is messed up. But the interesting part here is like that. First of all, this counter is still going up. Like the last time it was 320 when I made a screenshot. Now it's 350. But we have fixed this already in version 5. But the thing is, we got this feedback, I think, a couple of days after we've released the major version. Now, this feedback, even though it's not very polite, but this feedback would have been very good a couple of days or a couple of weeks earlier. So if there's one thing that I want you to take away from this talk, I want it to be this. Please help out maintainers of open source libraries that you're using by trying out beta versions and report feedback. I can guarantee you it's the best time to be heard. Because without that early feedback, mistakes like the one I made might make it into the stable version. But stable doesn't mean bug-free or battle-tested. It just means that we can't change the APIs anymore. And one example where giving feedback in those phases really paid off, I think, is for React itself. I don't know if any of you remember use mutable source. It was a hook that was supposed to ship in React 18, but it was then redesigned and renamed to useSync external store after some feedback from the React 18 working group. Then, of course, we had useFormState, which was renamed to useActionState just before the React 19 release to make it less confusing. And then finally, we had SuspenseGate, which I know nothing about. But the feedback around this suspense API led to the postponing of the React 19 release. They stopped it for almost half a year until they could fix it and ship this new pre-warming feature to prevent the waterfalls between siblings in suspense. So really, I think open source is a two-way street, and giving early feedback is one of the best ways to help out while also getting the most in return. Yeah, that's all I got. Thank you very much.